Hello, everyone. Welcome to the Agilent University Virtual Training Symposium. My name is Takashi Kondo, and I'll be hosting today's session. Today, we are presenting HPLC Tips and Tricks, presented by Joanne and Wong. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box in your control panel. We'll bring them up during the Q&A session at the end. Now, we will turn the time over to Joanne.
Hello, everyone. Today, I'm going to share with you some of the HPLC tips and tricks in this webinar. So the objective of today's will give you some ideas about everyday HPLC troubleshooting. I believe that some of you that have been using HPLC already has an idea of what maybe need to take note. But for today sharing, I want to start with like what it is important to know your baseline operating parameters. If changes occur, it will make it easier for troubleshoot. As you look at this slide here, during the course of your work, things that you really need to monitor is including like pressure. So later I will go more in depth about what are the pressure parameters that you really need to take note of. Baseline noise, retention time positions, area positions, peak height positions, peak shape and sensitivity. I believe that these are also the parameters that you are actually monitoring during your system suitability testing. I believe that you will definitely have questions like, is the problem related to application method or the instrument? So in that situation, you may considering injecting the standard mix into the hardware that you are currently using for the particular method that you think that the results is not as expected. When you inject the standards into the HPLC, you will also need to use the column that is reliable, a new column or the column that you always use it for the standard injections. The purpose of it is to find out whether the abnormal peak shapes may due to the instruments or the application itself. So what you can do is that you need to have a HPLC test sample that you always use to check your equipment, or you can use Agilent HPLC checkout standard as what our engineer usually do, which there is the 4 peaks, and then these are the compounds that are chemically stable in its sufficient concentration. Then usually you will use the test column like the C18 column that with the recorded length, internal diameter, or even stationary phase and the particle size. So by using the normal column that you usually use to check out the instruments, it can help you to have less variations when you want to compare against when the instrument is in good condition. Of course, the separation methods are also very important. Solvents that are used, flow rate, temperature, pressure, or even detection temperatures, all are the standard methods that you usually use to check the instrument, which ultimately it should give you the results that you want, which including the peak width that you expected to see, resolution, peak area, signal to noise, and etc. If you are coming from a pharma company, these are usually the qualification protocol that usually our engineer will use to test on the instrument condition. Okay, now next, let's look at what are the instruments modules that give you what kind of possible problems and how can you troubleshoot from it. As you see from the slide here, the top part is the solvent bottles. It's the same as what we have beside me here, which is the HPLC solvent bottles, followed by, in this example here, we actually have this auto sampler, and then pump, thermostat column compartment, and the detector. The one that you see on the slide are in the orientation of solvent, and then followed by detector, column compartment, sampler, and pump. With this flow here, both are optimized. It depends on your lab conditions. some may prefer to have one stack, some may prefer to have two stacks, depending on the height of your bench and depending on the lab SOP conditions. But most important is auto sampler and pump should come after one another. And then the auto sampler with column compartment should also come with one another. So auto sampler could be in between of a pump and a column compartment. The last one has to be a detector because that is for detection purposes. So in this slide examples that show in the slides, the solvent will actually go down to the pump, then it starts to flow upward to the auto sampler, where it controls the injection volume to be introduced into the column, and then followed by the column compartment, where that is the heart of the whole HPLC, where these columns will help with the separation. So compounds that retain stronger onto the column will tend to elute out later. But compounds that does not retain that long in the column may elute out earlier. And this helps with the separation of the peak. And then lastly, the compound will get eluted out from the column and then flow to the detector. This is where detection happens. That is when it is in a one stack condition. Why the pump may be at the lower part? It could be because of that pump is very heavy. So it really depends on the lab situations and the lab conditions. But in this example here, still the pump is at the lowest because it's heavier. But in this case, because of two stacks, what happened is the solvent will flow to the pump, and then the pump go upward to the auto sampler, sideways to the column compartment. So we want to have a minimal kind of tubing length. And then from column compartment here, the column inside will then to the detector. This is the flow of it. And this also will ensure that you will have an optimal result, which is able to give you a reproducible retention time, which is a key parameter for you to identify the compound. Because imagine when the two peaks, standard peak and the sample peaks, retention time are not similar, you may thinking whether this is the right compound that is being detected or that is something that is unknown. Okay, next, we really want to look into the type of problem that we usually face. So pressure problems fall into one of the three categories: high pressure, low pressure, or even fluctuating pressure. So pressure problem can occur suddenly or gradually. What does it mean of suddenly? Suddenly means that when your particles from the samples actually block your columns or damage the tubing, when they actually flow through the system, the pressure will suddenly shoot up. That is when there are some particles that are being stuck in the system. Pressure, it could be the salt precipitation. So the precipitation actually slowly build up, or the particles generated in the instrument debris may be coming from your valve septa or some of the degrading seal. So all these are slowly built up along the time. So, and that's how it happens with a gradually increase in pressure. Now we would want to go into pressure too high first, because that is the most common problem that usually face compared to a low back pressure or fluctuating pressure. Okay, so now I will go into showing you on the real hardware itself so that you have this better idea where could be the cause of the high back pressure on the instrument. Wherever you see in the slide here, these are the guidelines, which including like column inlets with contaminations or column contaminated, fluid purge valve, contaminated capillary, and etc. So now I want to go into the equipment by itself. I will go into the instrument now to show you which are the parts that usually cause high back pressure. But before that, I will also want to go through with you the flow of the solvent so you can connect between the flow of the solvents and the cause of this high bed pressure in each of the components in this HPLC. What you see here is the mobile phase. Usually, the mobile phase that are being used are organic solvents and water. So the organic solvent that usually being used could be like acetonitrile, methanol, or etc. Whereas for the water content, it could be pure water or it could be a salt buffer. So the salts like phosphate buffer, all these are being mixed together with the water. Because it may give you a better separation. So when you have a salt buffer with the acetonitrile being used as a mobile phase, you will really need to take note on the high bed pressure that may due to the precipitations of this salt because your water contains salt buffer. When it is in its own bottle, precipitation may not happen. Precipitation may only happen when both these solvents and salt buffers are mixed together. Because organic solvents and salt buffers, they don't really like each other. So when you have high organic solvent content, like 80% of it, and only 20% of the salt buffer, then you may start to see precipitation in these mixtures. Or if it flows through the system, then it may stuck along the line or in the components of this HPLC. When the solvent flows through, where the mixing happens? The mixing happens at the pump. So the solvent will first flow into the pump from this individual solvent tubing and go into this multi-channel gradient valve. This multi-channel gradient valve will draw the solvent ratio based on what you have set in your software, and then the mixing will then happen at the outlet of this tubing. So when the mixing happens from here onwards, and then to the pump head, they flow into the inlet valve here. If you look at this, this is the inlet valve. And then followed by the two pistons inside the pump head, outlet valve. And then they may go into the device here that monitor the pressure. It's shown inside the MCGV valve. After that, it will exit and then flow out from the purge valve. This is the purge valve. And then there will be a capillary tubing connect between the purge valve or this pump to your auto sampler, which is to this injection valve here. As long as the mixing already happened, when you are not running the equipment after your sample analysis, and yet you did not flush your instrument, they will start to have salt along the line here, or even inside the pump head, including like pump seal, or even inside all these valves that connected to the pump head, and also to the capillary tubing. And then when you flow through this capillary tubing, this is number one, there is an injection valve inside where they switch between the bypass mode and the main pass mode. When we say bypass, meaning that they are bypassing the needle seat, and then the solvent will go straight into the column. Bypass mode will only happen when the needle needs to lift up to draw the sample. But when the needles are not lifting up to draw any samples, injection valve will be always in a main pass mode. Main pass mode meaning that from number one, through the injection valve inside this, there's a rotor seal. They will flow through the rotor seal and then came out and then go to this metering device where they control the amount of sample being drawn for the needle. And then the solvent will then pass through the needle seat capillary back to the injection valve, and then it will switch to this point here to have the solvent to flow into the column. internal part of this injection valve are very small. Imagine when you have precipitation, salt precipitation inside the injection valve or the capillary tubing or even the pump head, you will start to see a high back pressure because of a very small internal volume. So this could be the reason why you see a higher back pressure, and it happens gradually. Next, we will look into the HPLC column. So the solvent that flow out from this line, this tubing here, into the HPLC column, which is this part, this is also a very crucial component that you need to take note of. HPLC column is the part where separation happens. And also this is where the sample will pass through. It is also the heart of the instrument. So this column has a very, very small particle size. This small particle size will require a fluid at both ends to protect the particles to drop off from the column. So usually when there is a choke, it will happen at the fluid portion. It's also to protect the column so that the contaminants don't go into the column, and also to protect the particles to fall off the column. But because of this fluid that has very small pore size, it will also have the back pressure to build up. Imagine when this fluid at the head of the column is being saturated with the particles. The solvent can't flow through here properly, and hence you will see high back pressure. When there is high back pressure, the flow into the column will no longer be consistent. It will then affect your peak retention time, and which ultimately your result may not be consistent. There is no recovery when the fluid is being choked. The only thing is that you need to change a new column. But how do I know whether the problem is due to the column or the instrument? So first thing that you need to do is you remove the column. When you remove the column, the back pressure drops down to the initial back pressure when your instrument is new. It shows that the instrument is fine. The problem is coming from the column. But when the back pressure is still high, even though you remove the column, meaning to say that the instrument also having some precipitation along the line, or even debris stuck along the line that cause the higher back pressure comparing to when the instrument is at the optimal condition without the column. Pressures play a very important part for the instrument, just like our human body, our blood pressure. Usually you monitor your blood pressure. You want to make sure that your blood pressure will not exceed, which is harmful to your health. Similarly, HPLC system will monitor back pressure as well to understand whether the instruments are in good condition or not, or even the columns are in good condition. So when the column is choked, you will need to change it. You can try to flush it with high organic solvent. It may or may not help. Yeah, if it can't recover back to the usual pressure, then you will need to change your column. Okay, what if due to the instrument means you have eliminated the column, but it's due to the instruments, you will start to wonder which part of the instrument that caused the back pressure. So how can you find out which part of it that caused the high back pressure? The first thing what you can do is you open the purge valve. When you open the purge valve, solvent will not flow to the auto sampler. Okay, if you open the purge valve, the back pressure drops, meaning to say that the pump is all right. There is no precipitation happen inside, because when you open the purge valve, means the solvents are not flowing into the auto sampler, and yet the pressure is low. And then it's the same as when it is at the optimal condition during the purge valve is open. It shows that the pump is in good condition, no high back pressure, no precipitation. Then you need to look into your auto sampler, because when you open it, the pressure drops. But when you close it, the pressure builds up. means back pressure coming from auto sampler. But how do I know in this auto sampler which is the portion that may cause the high back pressure? What you can do is you can disconnect the tubing one by one. First, let me recap the flow of the injection valve. Number one, which is here, number one, is the flow of the solvent to the injection valve, number one. Then from number one, there is a groove inside, transfer the solvent to number two, which is the next line. So number two will have solvent to metering device. Metering device then exit to the needle, which is here, needle seat, and then the solvent will flow to port number 5, which is here. From port number 5, there will be a groove in between to port number 6, where the solvent will then go to the column. So what you can do is that you start loosen from port number 1. So you trace on 1, 2, 4, 5, and 6. So when you remove port number 1, the pressure drops, meaning that the back pressure are coming from the later stream, meaning that it's inside the injection valve or needle seat, because the pressure drops. So then you close it, then you unscrew number 2. But what if you unscrew number 2? The pressure didn't drop, still maintain high. Means now the solvents are not going to the metering device, means never drop. Meaning to say that there may be a choke in the injection valve in this groove here. So you may want to consider to take this groove out to check, or tourniquet it, or change to a new one. But if, let's say, the pressure drops, meaning that it's not along the valve here, it could be due to the needle or needle seat. So when you unscrew it, the pressure drop, means it is safe along the groove here and the pump. Then it could be due to the needle or needle seat. Needle is the part where usually sample being drawn. If your samples are very crude, cannot be dissolved in your mobile phase, then it will stuck in it. And what happens is, when it's stuck inside, it will cause high back pressure. And then the sample that you are going to draw in your following injection no longer be consistent. Your aerial count will get affected because the amount of sample being drawn are no longer accurate. So you can also, similarly, as what I said, you can dismantle the last one, 5, the pressure drop. Means it's not due to the upper part here. But the pressure still maintain the same, means it could be a needle that is choked. Yeah, this is how you can try to find out which part of the auto samplers that cause the high back pressure. What I've shared earlier is mainly by testing on removing the nuts from each of the ports. There's another way that you can try out to check whether the choke or the high back pressures are due to the needle and needle seat. How can you do that? You can try out with bypass and main pass mode if you know how to control your software by changing the injection port to bypass or main pass mode. So in your software, there is this option where you right click, more options. You can see an option where you have this called bypass, main pass. This is where you can hear the switching of the injection valve. It will so it will switch in between bypass or main pass. So when it's in bypass mode, means it bypass needle and needle seat. When it's in bypass mode, the pressure is good, means low and optimal, meaning to say that the choke are coming from needle and needle seat. But when you switch to bypass mode, the pressure is still high, meaning the bypass and main pass, bypass mode, the pressure is still high, meaning to say that it is not due to the needle or needle seat. Or it could be due to needle seat somewhere else, but the problems are still not resolved yet. These are the things that you can consider: back pressure, due to salt precipitations happen on pump. Back pressure due to stuck at the needle or needle seat could be due to sample. Always remember, sample will only be introduced into the system from auto sampler. Your sample will not flow backwards to your pump. So always remember that any high back pressure in the pump is not due to the sample. Because when the samples are being introduced from the auto sampler, it will mix with your mobile phase and go straight to your column for separation and then to detector for detection purposes. So that is an overview about high back pressure. Next, we will go into the low back pressures and pressure fluctuation. Next, we will look into pressure too low. For pressure too low, commonly due to the solvent inlet feed may be choked. So inside this solvent bottle, there is a solvent inlet feed inside. So when this solvent inlet feed are covered maybe with algae or salt or any contaminants, the solvents that being drawn through the tubing here no longer be accurate, or they may have bubbles, or they may not able to draw any solvent at all. So when they can't draw solvents, you will see pressure too low symptoms. Other than that, it could be due to like wrong flow rate, wrong solvent. So sometimes you may use the wrong solvent. So you thought that it is the right one, then you realize solvent, the pressure is not right. That may be one of the reasons. Besides that, it could be due to the pressure measurement. So there is a pressure sensor in your pump. So in the pump head, nearby the pump head area or even an MCGV valve, multi-channel gradient valve, there is a pressure sensor. If your pressure sensor is faulty, meaning to say that it cannot detect the right pressure, and then it could be one of the reasons that give you low back pressure. Other than that, they may be due to valve, all the valve that is on the pump. So in your pump head, just now initially I mentioned that when the solvent pass through the pump, the first valve that they will pass through is called inlet valve. That's why it's the inlet of the solvent to the pump head. So the inlet valve, the valve will control the solvent to pass through. If the valve is defective, means they cannot control the amount of solvent to flow into the pump head, then it will also cause pressure too low. Similarly to the outlet ball valve, the exit of the solvent from the pump head to the damper or even the purge valve. So any of these valves is defective, it will also cause pressure too low or pressure fluctuation. Lastly, it could be also column defective, because maybe the stationary phase or bleed off, no more stationary phase, or maybe left half of it. Then it could be one of the reasons to cause low back pressure. So pressure fluctuation is very rare, but many are due to the solvents that being drawn. They cannot be drawn properly because of the solvent inlet feeds are choked, or maybe the degasser is faulty. So the purpose of degasser is to remove the gas in your solvent. Imagine the gas cannot be removed, but then now you cannot see any bubble, right? At high back pressure, you will see bubble inside because there is gas. But when they pass through the degasser will remove the gas coming from your solvents. And then when the solvents do not have any gas at high flow rate, high pressures in the pump, you will no longer have a bubble symptom. So when there is no bubble, you will not have pressure fluctuation problem. Of course, outlet ball valve, inlet valve, all these may also cause of the pressure fluctuation. So this is where you can try to slowly, step by step, to find out what could be the cause of the fluctuating pressure. So you may have a question like, was the pump primed properly? If yes, then you can move on to your next question like, are you performing a gradient analysis? If yes, maybe the pressure change follow the gradient that cause the pressure to change, which some people may say fluctuate, but it is normal because the change are gradually depending on the individual solvent's viscosity. But if it's no, then the next question you need to ask yourself is, are the pump head functioning correctly? So if it's not functioning correctly, then you need to do things like leak test. Usually how we want to find out whether the system is okay, besides looking at pressure, we can also perform some of the diagnostic tests, including pump leak test or pressure test. Pressure test and pump leak test can check whether there's any physical leak or internal leak when you perform the pump inlet leak, pump leak rate test, because they are checking based on the pressure, whether they can sustain the pressure at certain time range, certain flow rate, to determine whether there's any internal leak in the pump itself. And question you can also ask is like, are all the solvents being degassed? If yes, then you need to ask whether are they miscible. If it's no, then you need to check the miscibility. But if it's yes, you also need to check whether are the solvents volatile. If the solvents are volatile, yes, then you need to make sure the operating temperature is suitable for this solvent use and degas thoroughly. Imagine if it's volatile, but yet the temperatures in your environment is warm. Maybe the solvent will slowly get evaporated off, then the amount of solvent or even mixed with the water's contents will no longer be the same. And that will also affect the separation, the retention time, because the solvents are the mobile phase that play an important part in helping the peak separation. And then you can also ask questions like, is the pressure sensor working correctly? If it's yes, means problem seems associated with the pump. If it's no, then it could be due to the pressure sensor problem, and then you may need to find out what is the pressure difference and etc. Next, we will look into the auto sampler troubleshooting. Just now was about pump, now we go into auto sampler. So for auto sampler troubleshooting, usually the problem on auto samplers are more related to peak areas, not reproducible. Why? In your auto sampler, in the injection port, there is this rotor seal. Rotor seal has this force port leak. Means the injection valve itself, the groove on this injection valve may leak inside because of heat switching, right? Then you may have scratches. The scratches that is the part that causes the cross port leak. Or even sometimes if the injection valves are not tight enough, there is some internal leak. So all these leaks will affect your peak area because the sample being introduced into the column no longer be consistent, and sample amount means the sample being introduced will affect the area count. Or maybe the metering device at the auto sampler that I shown earlier that control the amount of the sample being drawn may be having some leakage as well. So if let's say the metering device seals are leaking, it will also affect the amount of sample being drawn to be introduced into the system or even column. Neither, block, all these also will affect the peak area. How can you check whether what kind of the problems from the auto sampler that affect this peak area? You can make use of checking the peak area linearity. What do I mean is that you can inject different injection volume, and then you plot a calibration curve to see whether this curve is linear or not. So you can start with like 0.5 mil of the sample, 1 mil of the sample, 2 mil of the sample, 3 mil, 4 mil, 5 mil. So this is the injection volume. You draw this volume, and then you inject into the column. When the result is out, then you plot to see whether the curve is linear. By right, different injection volume, the area count should increase gradually, or even the peak area should increase gradually, and that should give you a linear curve. If it's not linear, and the curve is not linear, it could be due to the rotor seal cross port is leaked, or injection valve is not tight, metering device fuels are leaking, or even needles are partially blocked. This is a diagram of how the auto-sampler works, and also to show you that the reproducibility problem that due to area count mainly are coming from the needle portion. Yeah. So if you look at this, peak area and peak height mainly due to auto-sampler. Peak area and retention time mainly due to the pump, because the pump is the part where it controls the flow of the solvent, the ratio of the solvent mixing. So what is the ratio of the organic solvent and water content? This will also affect the peak retention time. If you have problem with reproducibility, especially the peak areas, what could be the reason? So this is some of suggestion for you to refer to a guideline, but it's also similar to what I've explained on the heart rate itself initially. So a thumb of rule, remember anything related to peak area, peak height due to auto-sampler. Anything related to retention time, reproducibility, drive down to the pump. So here also another example giving you an overview of the reproducibility in terms of the retention time. So when you have decrease in retention time, what could be the problem? Or when you have increasing in retention time or even fluctuating in retention time, what could be the problem? So these are showing the inconsistency. How can you understand what could be? So you need to do a pressure tracing, a flow measurement, or even an injection check to check the linearity to make sure it's not due to the auto-sampler, but it is due to the pump. So you need to isolate them one by one. Here are further illustration based on the three groups, decreasing in retention time, not consistent, or even increasing. So what could be the possible cause? When you decrease in retention time, possible cause could be the column is overload. Yeah, so you may want to reduce in the amount of samples to see whether it helps to improve it. Or maybe the column stationary phase start to wear out, so there's loss of some of the retention of this compound, so they get eluted out earlier. Yeah, because there's not much surface in the columns in terms of stationary phase able to retain your compound. Sometimes it could be due to wrong pH being used. The stationary phase on the column will slowly degrade, especially when the method that you use are with very low pH range type of the mobile phase. Even wrong solvent composition may also cause the shift of the retention time towards the front. When there is a toward the back, increasing of retention time, it could be also due to the mobile phase. It definitely not due to the wear out of the column. As long as when the column is wear out, meaning that stationary phase no longer able to retain your samples, they tend to elute out earlier. But when your compounds elute out later, it's no longer due to your column stationary phase defect, but it could be due to wrong mobile phase are being used, or maybe the solvent mixtures are not correct. When it's related to solvent mixture not correct, you can think about whether is it somewhere in the pump head it's not working properly, or even wrong solvent composition, or bubble and etc. Or even fluctuating. So fluctuating could be due to the temperature. Maybe you do not have a column oven, you have your just column hanging outside of the system. So when your environment temperatures are fluctuating, if your methods are very sensitive to environment temperatures, then you will have a fluctuation in the retention time. Especially when your solvents are those very volatile solvents, at different temperature, the viscosity, the volatility all changes, the flow of the solvent changes, the miscibility of the solvent change, it will definitely affect your retention time because solvent characteristic will change at different visibility, volatility. Yeah. Sometimes it could be due to your method, meaning the buffer used, capacity may not be sufficient. And it also could be due to your columns are not being equilibrated properly. So you may, if you are running a gradient, when you change to a different gradient and then you need to do a next injection, but your column has not conditioned back to the initial mobile phase ratio enough, then it will also give you irreproducible retention time. So all these could be due to column when you have a lot of fluctuations. You need to consider what could be the cause of the columns based on what we have suggested here. It may not be due to the instrument itself. Sometimes maybe just change your column to another new one. It could help with the situation. Or maybe you can flush the column more with your initial solvent condition, may also help with the situation. This is just a repeat of what I've shared earlier through the instruments, especially when retention time is not reproducible, what could be the cause of it? Followed by peak area not linear, it could be the Reproducibility metering device. Here is just a more in-depth diagram for you to refer to so that you have a better idea how it looks like. So here has a Reproducibility, the needle, the metering device field. These are the parts that may cause the peak area not linear. Not linear meaning that when you increase the injection volume through the column, like 1 mil, 2 mil, 3 mil, 4 mil, 5 mil, you do not get a linear curve. The signal noise is the jitter of the signals over a short period of time, while the drift refers to the overall change in the signal over a long period of time. It's usually changed in either the positive direction or negative direction, shown above as a straight line under the jagger signal. Sometimes when your lamp is weak, means it's time to change, you will also have a drifting baseline, not a flat baseline. Yeah, so this could be the cause of it. If the flow cell is dirty, it will also have this kind of noise problem. So these are the possible causes, like flow cell dirty, mobile phase is dirty, and the lamp is failing, it's time to change. If you are using RID detectors, they are very sensitive to temperatures. These are the things that you need to take note. Gradient illusions or even immiscible solvent. This is just a guide for you to find out whether the baseline problem is due to the pump or due to the detector. So when there's a baseline noise, you stop your pump. Means you don't need to have a flow. You put 0 mil per minute, and then you monitor how the baseline looks like. So if the baseline still persists, means it is due to the detector, because now you already stopped the flow of your pump. You do not have any solvent coming from the pump anymore. But when you off the when you off the pump, the noise still persists. It means a boil no longer persists. Means stable. When you off the pump, no more flow, but the noise also resolved, means it's due to the pump. Maybe the mobile phase is not clean. Yeah, then you need to check on it, or maybe there are some problem due to the mobile phase composition, miscibility, and etc. Sometimes it could be also due to some mixing problems, like what you see on the slide here, because of UV detector. So the UV detector will absorb the mobile phase, and then when you mix with those non-UV absorbing mobile phase, you will have this kind of problem. So what is the solution to it? Add a mixer to help with the mixing of two different mobile phase come together. Gold stick could be due to the column, contamination in the needle or needle seat. Yeah, and lastly, the sensitivity could be due to the lamp is weak. Time to change the lamp. When the flow cell is contaminated, you will also need to change it because it will also affect the sensitivity because the lens are being blocked, so the light can't shine through properly, the absorptions are not there, then the sensitivity of the peak will drop. Other question that you can ask yourself, have you changed your mobile phase composition, or you may need to understand whether the vendor, the mobile phase slot, is it changed, and then if that could be one of the cause of this detector problem. You can also ask yourself about, have you changed your acquisition wavelength? What mobile phase are last used in your instrument? Do you have a miscibility problem? Are your solvent dirty? These are the questions that you can ask yourself when you come to troubleshooting your detector. Lastly, you must always exclude that it's due to applications before you really go and check onto the instrument. Sometimes, if you never exclude the application and then you troubleshoot, spending a lot of time to troubleshoot the instrument, and then lastly you find out it's due to application, you are actually spending a lot of time just on the instrument rather than a simple solution that is due to some setting on the application. So you need to take a methodical and systematic approach, localize the error in a part of the system, just like what I shown earlier. You can unscrew some of the connections and then to check on the back pressure. Always remember to change one thing at a time. Yeah, don't change all and then end up you do not know what is the root cause of it. Ask for help whenever it's appropriate. Plan the course of action. So wherever you have changed, note it down, put into SOP. So in future, whoever still face the same problem, they can just base on the SOP to verify it and then to change it accordingly. Lastly, if today's session was worthwhile for you and if you would like to have a further learning from us, we will offer a wide range and cost-effective training course option to support you and also to able to reach your goal. We offer 3 different types of education styles, including like classroom training. For those who ever attended our classroom training, I hope you enjoy it. We also have virtual instructor-led training, similar to what I've shown earlier. So we have this theory, and then yet at the same time, we will also show on the instrument to give you have a better idea. But of course, you can also combine your virtual instructor-led training with a hands-on training where it happens in our lab here. And we also have a self-paced e-learning course. So when you go into our website, you can always log in and then find out some of the recorded online course for your reading and understanding before you decided to go for more in-depth training in our site here. Feel free to visit our agilent.com training page for more details. We also have this course catalog for your reference. This is the QR code that you can scan, and then it will lead you to our AU website. Last but not least, we will definitely have more detailed training for you. Whatever I've shown here is some of the preview and tips and tricks for your reference. So we have like course, technical HPLC course, maintenance and troubleshooting course, CBS 2.x software course, and also camp station course. Feel free to contact us anytime for further inquiry on the interested training course. Thank you for your attention.
Thank you, Joanne. Now, we will go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the question box in your control panel. Also, you will about to see simple polling questions on the screen. We appreciate your feedback on these as well, and we will give you a few seconds for you to go through them. All right. It looks like we have a few questions. Hey, the first question is, to get optimum peak performance from 1200, 1200 and 1260 series of HPLC system, what should be considered? Joanne, please.
Thank you, Takashi. You need to make sure that your sample preparation is adequate to the HPLC. And you also must make sure that you use HPLC grade water. Always filter your solvents before you use it. And one thing that you must consider is the miscibility of the solvents. Especially if you are using salt buffer, you need to ensure that the salt mix well in your water, and also when the solvent and water are mixed together during your gradient run, at any percentage concentration, the salt will still be miscible well in the solvent itself. Before you perform any sample analysis, you need to also purge your HPLC system with a mobile phase, equilibrate your column and stabilize the column oven temperature, and check the detector to ensure a stable baseline before you start any run.
Okay, great. The second question, what is the frequently replaced consumables during pump maintenance?
As shown earlier in also the video, the slides, usually when you perform pump maintenance, the main thing that we change is pump seals and fluids. These are very common consumables that you need to change every half yearly. It also depending on how frequent you use your instrument. If your instrument is heavily used, it is recommended to change even every 3 months. The pump seals is the part that when it's in the pump, it easily get wear out because it's wear and tear consumables. And also the fluids that is located in the purge valve, it will get choked easily because it actually filter off any contaminants from your mobile phase. If your mobile phase is not pure enough, the fluid will get choked more frequently. So besides replacing pump seals and fluid, you will also need to clean the piston and the internal pump head area, ensuring that there is no scratches and free of salt precipitations. In addition to it, you will also need to clean and replace the outlet and inlet valve, the consumables that I've shown earlier in the video. Some you can consider to sonicate it if let's say it's choked, but after sonication, if it's still not usable, then you will need to change the valve. Thank you.
Okay, thank you very much, Joanne. There's more questions. Okay, I'm currently having trouble with the linearity test, and I don't think the problem is HPLC itself. Could it be possibly because of the type of sample vial?
Sample vial, possible. I need to look at the chromatogram itself and what has been happened for this analysis. So what it could be due to sample vials, especially the scepter, because the scepter of the sample vials may have reactions with your samples that affect the linearity. But first of all, we need to separate these two things to check it out whether is it sample vials, method itself, or the instrument. So if you still recall that the video that I've shared earlier, first of all, I will need to check the linearity by checking on the auto samplers is performing well, where I inject different injection volume of a standard checkout standard. So I inject 1 microliter, 2 microliter, 3 microliter, up to 5 to check whether I get a linear curve. So if let's say the curve is linear, 99.999% of the efficiency, and means that the instruments are not an issue with a standard checkout standard, with a standard column, then if this happens only on the samples that you are running, or even on a particular column that you are running, then it could be due to some reaction of the sample with your sample vials, or it could be due to your column. So we need to troubleshoot it step by step. First, isolate whether is it due to instrument problem. If the instruments are in good conditions, then you move on to check out whether is it due to column or your sample vials, if you suspect it's due to sample vials. Yeah, thank you.
Okay, thank you, Joanne. There's another question. What is an ideal equilibrating time before running at starting conditions of your method?
Thank you, Takashi. So for the equilibration time, it is very depending on what mobile phase you are using for that method. So imagine this method is not a simple reverse phase kind of mode methods for your HPLC, meaning that it requires some ionic strength where your mobile phase contains some salt buffer like phosphate buffer, or even some acid like acetic acid or acetic acid. So when you have all these additives in your mobile phase, your column will need to equilibrate long enough, because the column, the stationary phase in your columns need to be in the conditions where it has been treated by the mobile phase. So the equilibration time is it's also very depending on the length of your column. Imagine if you are using a 250 centimeter column, very long, and also the ID is big, 4.6 mm, then you will need a longer time. It could be 2-3 hours. Or if let's say you are using a very small column like 50 centimeter, and you are using a small ID, probably 2.1 mm ID, the equilibration time definitely will be lower. So it varies based on the method you are running, because the mobile phase that you are running is crucial to the time needed to equilibrate a column, and it also very depending on the column dimension. So you will need to re-look into your method, what mobile phase you are using, and then of course not just that. When you develop a new method, you actually tested with different conditions. You will start with 1 hour whether it is sufficient, 1.5 hours whether it is sufficient. Sometimes it may be only 30 minutes. So it really depends on what method you are using. So for simple basic methods, normal reverse phase, just acetonitrile and water, 15 minutes to 30 minutes is sufficient. If let's say your methods contain a lot of salt buffers and the column is very long, it could take 1 hour to 2 hours for every equilibration. Especially I understand if you run gradients, when you are back to the next injections, your gradients at different mobile phase, and then you need to go back to the original conditions, then it takes like 1-2 hours, which are pretty time consuming. So that's why a lot of customers, they're actually looking into a shorter column, because it shorten the equilibration time, and of course they look into how to optimize their method to make it better. Thank you.
Okay, it looks like we have one more question. So we still have a little bit of time, so let's do this one as well. Is the ripple value the only indicator of a stable baseline equilibrium?
Okay, so for the ripple value, it's not the only indicator. We also need to look at the pressure of the systems. What is the back pressure? So if let's say your back pressure is very high, it also shows that the systems is not at the optimal conditions. So beside ripple, you look at the pressure, and yeah, sometimes the compressibilities may affect the ripple. So the ripple is one of the indicator, but not the
Okay, it looks like Joanne is having some technical issues. We apologize about that. We will contact you separately offline to answer the question we were going through at the very end. So we'd like to wrap up this session, and thank you everyone for. We appreciate you being here today. And please take a look around the virtual site. Visit our booth, breakout room, and software center to download the latest product, consumables, and services information. Also, on-demand contents are available in Auditorium. Please check them out if you have missed any of the past sessions. And we also would like to have your feedback. Please complete our general survey in the lobby of the virtual site. Thank you again for joining us today, and we will see you next time.